Today we're going to talk about an important example of rearrangement including electron deficient oxygen. The example is Baeyer-Villiger rearrangement. In Baeyer-Villiger rearrangement, ketone on treatment with peracid give ester. By oxy-insertion, reaction is catalyzed by the presence of acid catalyst. The reaction is showing the oxy insertion inside this ketone molecule and an ether is producing. Reaction is particularly useful for the synthesis of lactones. Following is an example of the lactone molecule. Mechanism. First step is addition of peroxyacid to carbonyl carbon leading to a tetrahedral intermediate. In the next step, concerted migration of the migrating group and loss of carboxylic acid provides the product. Migration group and loss of carboxylic acid is providing two products which are acid and an ether. The mechanism is supported by the fact that oxidation of this compound pH2 carbon 18 and oxygen yields only pH carbon 18 OOPH. There is no scrambling of 18 carbon label in the product ester. The loss of carboxylates and migration of R is concerted, as the reaction known to be faster when electron withdrawing substituents are present in the leaving group and electron donating substituents in the migrating group. If migrating group is chiral, then stereochemistry is retained. The migratory aptitude in the unsymmetrical ketones as carbon at the maximum, then tertiary, and then cyclohexyl, and then secondary, and then benzyl, and then aryl, and then primary, and then methyl. In the case of aryl group, migrating ability increased by electron donating groups present on the ring. Following is an example showing the insertion of oxygen. Migration is favored when migrating group is antiperiplanar to oxygen-oxygen bond of leaving group is known as primary stereoelectronic effect. Antiperiplanar alignment of lone pair of electrons on oxygen with the migrating group is termed as secondary stereoelectronic effect. In case of unsaturated ketone, epoxidation is likely to be a competitive reaction, but Baeyer-Villiger rearrangement is favored because ring strain can be relieved by oxy insertion and ring expansion. Chemoselective oxidation of beta-lactam has been achieved with MCPBA in DCM, where only formates are formed in better yields. One of the most important synthetic use of BV reaction is found in the synthesis of L-DOPA which is a drug used in treatment of Parkinson's disease.